I bring you greetings from the throne room of God. I hope you are all doing well. Today is our 5th session of the science class. I hope you've taken time to go through the questions that we've looked at in the previous sessions. In our last session, we've started looking at related questions under preparation of gases. We're going to continue today by looking at question 14, by looking at question 12, 13, 14, 15. If there's time, we also look at question 16. So without much ado, we're going to start from question 12. Now question 12 reads, it says the setup below is for the preparation of nitrogen from air in the laboratory. So use the answer, use it to answer the questions that follow. So it says the setup below is for preparation of nitrogen from air in the laboratory. Use it to answer the questions that follow. So you have the diagram given, and based on the diagram, you have some questions. The question A says, name the parts of the apparatus labeled I, and III. So we're looking at question 12. A. We are supposed to label the parts I, and then III. Okay, so the part labeled I is a glass tube. By the previous section, I told you that whenever you have an apparatus and it is being heated, you've got to indicate, you have to indicate or name the apparatus by adding the word hot. Because if it is a normal apparatus and heat, it will end up breaking. So you have to add the word hot to the apparatus. So for instance, if it is a test tube, we say hot test tube, or we say Paris test tube. So I is a glass tube, but because the glass tube is heated, you add the word hot. So we say hot glass tube, or you say Paris. So Paris, as I said, you can use the word hot. Glass tube. Okay. And then the part labeled II. The part labeled II is the beehive stand. And then the part labeled III is the trough or basin. Okay, so that is for A. Now B. The B says, should give the function of each of the following in the setup. So you're supposed to give the function of I, potassium hydroxide solution. So function of potassium you are supposed to look at the function, or state the function of potassium hydroxide solution. Now, before I even state the function of the potassium hydroxide solution, you should have in mind that we are obtaining, or the question, the setup provided is to obtain nitrogen from air. So first of all, you should know the components of air. So you should know the components of air. So if the component of air, you have nitrogen. So you have nitrogen gas. You have oxygen gas. You have carbon dioxide. You have inert, or we also call them noble. We also call it rare gases. Rare gases. Examples of these gases, you have helium, neon, you have argon, we have krypton. I'm writing this in full because that one you don't know. And then we have xenon. These three are part of the first 20 element, but these ones, they are not part of the first 20 element, but they also fall under inert gases. They fall under group 8 element, group 8 elements. And then we also have water vapor. Okay, so these are the components of air. And out of this, you want to obtain nitrogen. It means that for you to obtain the nitrogen from air, all the remaining gases have to be what? Removed from the air. Has to be removed from the air, so that you be left with the nitrogen gas. So what is the role of the potassium hydroxide? The potassium hydroxide in the setup is to absorb the carbon dioxide present in the air. So that's the role of the potassium hydroxide, to remove the carbon dioxide that is present in the air. Okay. So that is the function of the potassium hydroxide solution. So it removes the carbon dioxide gas that is present in the air. Now the ice is copper tannins. Copper tannins. Now, so what is the role of the copper tannins? Or sometimes it's called copper chips. Chips. Instead of tannins, you can copper chips. Or pieces of copper. Okay, any of them is the same thing. Now, what's the role of the copper tannins? So first, we've talked about the potassium hydroxide. We said that one removes the carbon dioxide. Now, the copper tannins react with the oxygen gas that is present in the air. So the potassium hydroxide has removed the carbon dioxide. The copper tannins also react and remove the oxygen gas that is present in the air. Okay, so that is the function of the copper tannins. So that one removes the oxygen gas that is present in the air. And the last one is the apparatus labeled As part of the question A, we are not asked to label the apparatus IV. But if you were supposed to label IV, your IV is an empty gauger. Empty gauger. Or probably, let me put it as terracing, in case you are asked to label it. You are not asked to label. So that is an empty. No, it's an empty bottle. So empty. Empty bottle. Okay. So I've put asterisk there because it is not part of the parts you are supposed to label. So the function of the empty bottle is it prevents water from being sucked back into the glass tube. So that's the rule or the function of the empty bottle. It prevents water from being sucked back into the glass tube. Glass tube. What does it mean? You see, during the heating process or during this reaction, where the copper is combining with the oxygen, you have water vapor as a gas entering into the empty bottle. It will condense into water. And so the empty bottle there is ensuring that that water does not enter back into the glass tube. Does not enter back into the glass tube. Okay. Now let's look at the last question. Question C. Question C says, name one gas which is likely to be collected in addition to nitrogen. So let's come back here. The potassium hydroxide solution has removed the carbon dioxide. You also have copper tannins reacting with the oxygen gas. The water vapor that is formed it condenses into water, is collected in the empty bottle. So what it means is that you are left with the nitrogen gas and then the noble gases. So the question is asking that name one gas which is likely to be collected in addition to nitrogen gas. So it means that apart from the nitrogen gas, any of the noble gases can also be collected. So you just have to name one of the noble gases. So it can be any of this: helium, it can be neon, it can be argon, it can be krypton, or it can be xenon. So you just have to list any one of them. Okay, so that is all for question 12. That is all for question 12. Quickly, we're going to continue by looking at question 13. Question 13. Okay, question 13. It says that the setup below is for the preparation of iron-free chloride in the laboratory. So here you are not preparing a gas, it's rather for preparation of the compound iron-free chloride. So the diagram is given, and below the diagram you are supposed to answer some questions. Question A says name the materials labeled I, and I. So for A, we are labeling the materials I, and then I. Okay. Now bear in mind that the question says we are preparing iron-free chloride. That is the compound or the product that is formed. So iron-free chloride is this. You are preparing this. So how do you arrive at this? This is a reaction between iron and then chlorine gas, to give you the iron-free chloride. If you want to balance, you put chlorine here is 3 days 2, so you put 3 here to make it 6, and then you also put 2 here. So this is actually the balance equation. So it means that the reactant there is the iron and then the chlorine gas. And as part of the setup, you've seen dry chlorine gas indicated. It means that the other reactant that is left will be the iron. So you have the part labeled I. So the part labeled I, they represent the iron, because it's the iron which is going to react with the chlorine gas to form the iron-free chloride. So the I there is iron. So iron filings, or you can see iron chips or pieces of iron. So iron filings. Okay. Then your II, just like question 12, your II is the hard glass tube. And then your III, it's okay. Your III is actually a drying agent. So you have calcium chloride. So that is for the A. Now the B says it says state the function of the material labeled III. So you're looking at the function of this. So this, the calcium chloride there is acting as a drying agent. So the II serves as a drying agent by absorbing moisture. And the C says you should write down the balance equation for the reaction that takes place. So I've already even written the reaction. So you have iron reacting with chlorine gas to give you the iron-3 chloride. Balancing, you put 3 here, you put 2 here, and then you also put 2 here. So this is the balance equation. This is the balance equation. Now, the D says, what will be the color of the iron 3 chloride produced? Okay, so iron 3, the color of iron 3 is reddish brown. So we have reddish brown. So the color of the iron 3 chloride produced will be reddish brown. Now, if it was iron 2 chloride that is formed, color of iron 2 is light green. Light green. So if it is FeCl2 that is formed, then that would be light green. Light green. Or I can say pearl green. Pearl green. But because it's iron 3, it is reddish brown. Reddish brown. Okay, question E. EI says, why should the preparation of chlorine gas in the laboratory be carried out in a fume chamber? In a fume chamber. Okay, now it is important for you to know that the fume chamber, it is used for preparation of poisonous gases. Gases that are toxic. So that during the preparation, the one who is preparing the gas does not come into direct contact with the gas. Because the gas is poisonous, you end up becoming choked. So that is why we have a chamber in the lab called the fume chamber that is used for preparing poisonous gases. So, and chlorine gas is a poisonous gas. So that is why it is prepared in the fume chamber. Okay. So why is chlorine gas prepared in the fume chamber? Because it is a poisonous gas. So chlorine gas is prepared in a fume chamber because it is a poisonous gas. Okay, the EII says you should give, you're supposed to give 2 uses of chlorine gas. So uses of chlorine gas. So it is used in the purification of water. So chlorine is used to purify water for domestic use. So during the purification of water, water that is pumped into our homes, chlorine is added to kill the germs in the water. So that is one use of chlorine. It is used in manufacture of plastics. Like PVC, polyvinyl chloride. is also used as a bleaching agent. A bleaching agent in the textile industry. Okay, let me also add this. So it's also using it is used to produce antiseptics like Dettol. Okay, so these are some uses of chlorine, and you were supposed to just give one, but I've given you 4, so you can just choose one. And that also concludes question 13. Question 13. Question 13. Okay, we're going to continue by taking a look at question 14. Question 14. Okay, question 14. Question 14 says, the diagram below shows the setup for preparing ammonia gas in the lab. So here, the gas that is being prepared has already been stated. So the setup is for preparation of ammonia gas. Ammonia gas. And in our previous session, I told you that in preparation of ammonia gas, you need an ammonium salt and a base. So a compound, a salt that contains ammonium, NH4, and then NH4 plus, and then a base. And I give example as ammonium chloride reacting with sodium hydroxide, or it can be ammonium chloride reacting with potassium hydroxide. So those would be the reactants for preparation of ammonia gas. So the question A is asking that name the reactants labeled A. The reactant labeled A. So it should therefore be ammonium salt and then a base. So reactant labeled A should be 1, ammonium salt, specifically ammonium chloride. And then 2, the base calcium hydroxide. Okay, so those are the reactants. Question B. It says what suitable substance could be used to dry the gas and why? So if you look at the setup for preparation of ammonia gas, the drying agent used is the calcium oxide. Calcium oxide. So that is it. So reason, it serves as a drying agent by absorbing moisture from the gas produced. Okay, and then C. C says how, okay, we have CI and then II. The I says, or the C says, how would you identify the ammonia gas? I, chemically, and then II, physically. So chemically, that means you are looking at a chemical test for ammonia gas. A chemical test for ammonia gas. And then II, physically. So a physical test for ammonia gas. Okay, first of all, chemical test. I told you that in testing for ammonia gas, you make use of what? Hydrogen chloride gas. So you bubble the gas through a test tube containing the hydrogen chloride gas. And then the formation of white fumes indicate that the gas is ammonia gas. So that's how you test for ammonia gas chemically. Right, so the gas, is introduced into a test tube containing hydrogen chloride gas. The formation of white fumes shows that the gas is ammonia gas. Okay, so if you introduce a gas into a test to contain hydrogen chloride gas, and then you see the white fumes, the vapor coming out appears white, then it shows that the gas you are testing for is ammonia gas. Now, but how do you also show that the gas is ammonia gas physically? I told you that from the list of gases we're looking at, it is only ammonia gas that is what? A basic gas. A basic gas. So all they have to do is you are testing, you are describing a test to show that ammonia is a basic gas. So that is a physical test. And to show that you make use of the litmus paper. And what we did in acid, bases, and salts. Remember that I told you that the color of litmus paper in an acid is always red. Meaning that if you put a blue litmus paper in an acid, it will turn to blue. It will turn to red. It will turn from blue to red. And if you put a red litmus paper in an acid, it will still remain red. It will not change. And then the color of litmus paper in the base is always blue. It means that if the litmus paper is red, it will turn to blue. If it is blue, it will remain blue. That is, it will remain unchanged. So to test that ammonia gas is a basic gas, which is actually the physical test, we make use of a red litmus paper. So when you dip the red litmus paper into a test tube containing the ammonia gas, if the red litmus paper turns into blue, that shows that the gas is ammonia gas. Okay. So a moist red litmus paper is dipped into a test tube containing the gas. So if the litmus paper turns blue, it shows that the gas is ammonia gas. Okay. So that is for CII. So as you just dip a damp or moist red litmus paper into a test tube containing the gas. When the litmus paper, that is a red litmus paper, turns blue, it changes from red to blue, then it shows that the gas is ammonia gas. Now let's look at the D. The D says that it says write a balance equation for the chemical reaction involved in the chemical identification of ammonia. So you are looking at the reaction involved here. So here you are passing the ammonia gas through hydrogen chloride gas. So the reactions between the ammonia gas and then the hydrogen chloride gas, and this forms ammonium chloride. Ammonium chloride. And this is responsible for the white fumes. So white fumes, or I say white precipitate. So that is what is responsible for the white fumes, the ammonium chloride that is formed. Okay, so that is all for question 14. Question 14. Quickly, we're going to look at question 15. Question 15. So question 15 says the figure illustrates a setup used for preparing carbon 4 oxide from dilute hydrochloric acid and calcium triazocarbonate 4. So here the question is saying that the setup in the diagram is for preparation of carbon 4 oxide, that is carbon dioxide. So the gas that is being prepared is carbon dioxide, and the reactant has also been given, that is dilute hydrochloric acid and calcium triazocarbonate 4. So we have the name of the gas being produced, and we also have the reactants. Okay, so study carefully the setup and answer the questions that follow. Question A says identify 3 errors in the setup and suggest appropriate corrections. When we started with preparation of gases, I explained certain things. That if you have a diagram given, there are certain things that could serve as source of errors. So this question is addressing what I said earlier on. So question A says you should state 3 errors and suggest appropriate corrections. So I'm going to put that in a tabular form. So we're going to give the error, and then we also state the appropriate correction. Okay, so you are supposed to state 3 errors from the diagram. Now, if you remembered what I said in our previous session, I told you that the tester funnel, which is actually used to contain the hydrochloric acid, that tester funnel must be immersed or must be inserted into the solution in the flask. But if you look at the diagram, the tester funnel is outside the solution in the flask. So that is one source of error. So the part labeled M is outside the solution in the part labeled K. The tester funnel. So the tester funnel is outside the solution, the flat bottom flask. What will be the correction? So the tester funnel must be immersed into the solution in the flat bottom flask. Okay, so that is one error. and then the precaution or the correction. Now, what is the second error? What is the second error? I also told you that when you have a setup in which there is a basin containing the beehive stand on which the gas jar is, your delivery tube must be immersed or must be inserted into the beehive stand. But if you look at the diagram, the delivery tube is outside. It's outside the beehive stand. So that is one source. So the delivery tube is outside. The beehive stand. The correction, it should be inserted into the beehive stand. So the delivery tube. Okay. So that is our second error. Now the last one. So from the preamble, as I said, the question says that you are preparing, or the setup you use to prepare carbon dioxide. And in the preparation of carbon dioxide, there is no source of heat. So the presence of a source of heat, that is the benzene burner in the setup, is an error. It's an error. Okay. So the presence of a source of heat is an error. So the precaution or the correction is that the source of heat should be removed. Okay, so those are the errors associated with the diagram and the precautions or the corrections that you need to take. So the first one, the tester funnel is outside the solution in the flat bottom flask. To correct that, the tester funnel must be immersed or inserted into the solution in the flask. And then secondly, you have the delivery tube, the one that is carrying the gas from the flask into the basin containing the water. That delivery tube is outside the beehive stand. So to correct it, the delivery tube must be inserted into the beehive stand. And lastly, from the diagram, there is a source of heat and preparation of carbon dioxide using an acid and a carbonate. That is the dilute hydrochloric acid and the calcium carbonate. You don't need a source of heat. So the presence of the source of heat there is also an error. To correct it, the source of heat must be removed. Okay. Now we're going to look at question B. Question B says you should label the parts K up to R. So you have K, L, M, N, O, P, Q, and then R. Okay, so K. The K is the flat-bottomed flask. We have the flat-bottomed flask. Then the L. The L is the cork. The M is the tester funnel. Please, the spellings are very important. Sometimes you conduct test exams, students have funny ways of spelling this word, tester funnel. So please take note of the spelling. They have N. The N is a delivery tube. They have the O. The O is a gas jar, but it has been turned upside down, so that is inverted gas jar. As I said, you can say gas cylinder. And they have the P. Q. Okay, you have the P. Now the P is pointing to okay. Some people have been complaining that they can't actually see where the P is pointing to, but the P is pointing to the beehive stand. The beehive stand. Okay. Okay. If it is pointing to the container, if you see it as the container that the water is in, then that is the basin or the trough. And please bear in mind, if you also have this is the basin containing the water. This is the beehive stand. So this is the beehive stand on which the gas jar is on. And you also have this. There's a diagram. If you are supposed to label this, this is a wooden block. So wooden block. So if you are supposed to label this, then that is the wooden block. That's the wooden block. So you've gone through this. I said, so this is actually the beehive stand. And then this one, the one that the water is in, is the basin or the trough. Okay. And then whatever the basin is sitting on, that is the block, wooden block. Okay. Now, we are left to the Q. Your Q is the source of heat. That is the benzene burner. As I said, that is the same as the source of heat. And then lastly, the R. The R is the retort stand. Retort stand. Okay. Now the C. Question C. Question C. It says that write a balance equation for the reaction. So from the preamble, we have the reactant given as dilute hydrochloric acid and calcium triazocarbonate 4. So the reaction between dilute hydrochloric acid, that's ACl, and then calcium triazocarbonate 4, which is CaCO3. Your products are calcium chloride plus water plus the carbon dioxide gas that is produced. In balancing, you put 3. I expect all of you to be able to write down this balance equation without any problems. Because we looked at this in theory work. How to write down products when reactants are given and how to balance the equation. How to balance it. And then the last question, question D. It says, how would you test for the gas? So how do you test for carbon dioxide? I told you that in testing for carbon dioxide, you make use of what? Lime water. So you pass the gas or you introduce the gas into a test tube containing lime water. And then when the lime water turns smoky, it shows that the gas is carbon dioxide gas. Okay, so the gas is bubbled through a test tube containing lime water. When the lime water turns murky, it shows that the gas is carbon 4 oxide. Okay, so that is how it tests for carbon dioxide or carbon 4 oxide gas. So you pass the gas through a test tube containing lime water. And then when the lime water turns milky, it shows that the gas is carbon 4 oxide. That is carbon dioxide gas. Carbon dioxide gas. Shows that the gas is carbon dioxide. Let me put this here. Just like the previous question, you were asked to give an equation for the chemical test for ammonia gas. You can also be asked to write the equation for this, what is happening here. So the equation for test for carbon dioxide gas. The lime water you are seeing there is calcium hydroxide. So your calcium hydroxide is the lime water. And you are passing carbon dioxide gas through it. You're going to form calcium carbonate. So you have this aqueous plus this, the gas. You're forming calcium carbonate and then water, where is liquid. So calcium hydroxide, this one is the lime water. And then this is the carbon dioxide. When it forms this, so this is what is responsible. This gives you a white PPT, precipitate. So that is what is responsible for the murkiness or the cloudiness. So the calcium carbonate that is formed is what produces the murkiness. So take note. So that is the equation for test for carbon dioxide. test for carbon dioxide. Indian. Okay, so that ends question 15. We're going to end here today. The next time we meet in our next section, we're going to look at the remaining questions and the preparation of that. That's question 16, question 17, and then question 18. Question 18. And then when we are through with those questions, the last thing we will look at under chemistry practical is titration. So please, you can take your time to go through the remaining 3 questions that are left under preparation of gases. That's question 16, question 17, and then question 18. As I've always been saying, make sure you stay home and you stay safe. Make sure you continue to spend time, quality time, studying your books. Actively participate in all the discussions and interactions that are going on the WhatsApp platform, as well as on the online Edu TV. Please, we don't know when school will resume. As I said, it will be that when school resumes, examinations start straight. So please, don't be joking and playing around. Be sleeping and doing unnecessary stuff. Use this time to study and prepare adequately for the examinations. Until we meet again, God richly bless you.